Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be discussing on the topic mole, and we are going to be looking at the preparation of molar solutions. So, in the previous lesson, we discussed on concentration and how we calculate. So, it is important for you to go through that first before you come to the preparation of molar solutions. So we'll do a few practice questions afterwards so that we can be able to understand what we have learned. So when we are preparing a molar solution, you take for example, of sodium hydroxide solution. First, we will weigh 4 grams of sodium hydroxide pellets and put it in a 250 volumetric flask. You add some distilled water, some amount. Doesn't have to be specifically 200 centimeters cubed. And then we close the flask and then shake it vigorously until all the solid has dissolved. Then we are going to add the water slowly up it reaches the 250 centimeters cubed mark. So that is the process of formation of a molar solution. So it is important for you as you continue adding so that you can reach the mark, you ensure that the meniscus is touching on the mark. So the meniscus is the lower, you can see the lower part of the water when you are reading the value is supposed to be on the mark. So make sure you are able to do that correctly and you see the volumetric flask that we are using for this experiment. So, for example, the questions in regards to what the experiment we have just looked at. So, calculate the number of moles of sodium hydroxide pellets in 4.0 grams. 4.0 grams. So, when we come to the calculation of moles, we already discussed this before. So, we said its moles is equals to mass over molecular mass. So the moles for our question is going to be 4.0. Our molecular mass for sodium hydroxide is going to be 23 plus 16 plus 1, which will give us 40. So 40, so it's 4.0 divided by 40 so that we can get the moles to be equals to 0.1. And then the next question is calculate the number of moles of sodium hydroxide pellets in 250 centimeters cubed solution in the volumetric flask. So remember the 4.0 grams of the sodium hydroxide solution, so the ones that were placed in the 250 centimeters cubed of volumetric flask. So if you were to look at the number of moles in 250, they are equal, doesn't change. The only difference that is changing is the volume. So we will say it's 0.1 moles still that are in the 250 centimeters cube. Then finally, in 1 liter. So if 0.1 moles are in 250 centimeters cubed, what about in 1000 centimeters cubed? So it's going to be 0.1 times 1000 if you cross multiply, divide by 250. This is going to be 0.4, and remember it's molarity per 1 liter, which is the same as molarity. Those are moles per liter. Let's do a few more examples now in relation to how we prepare molar solutions. So for accurate concentration, one must be careful using measuring apparatus such as volumetric flask, pipettes, and burettes. Accurate measuring is very, very important. So when you are doing your calculation, it is important to leave your moles in appropriate figure, significant figure. Normally, usually recommend 4 significant figures so that you don't have like a large error. And then it is important to like be able to do the experiment carefully and produce good results. And then also ensure that apparatus are extremely clean when you're doing the preparation, and always use volumetric flask because they give accurate volumes. Do not use beakers or measuring cylinders. So let's do the examples. So what mass of lithium phosphate, so you have been given the lithium phosphate, would you need uh, to make 2.5 liters of 1.0 molar lithium phosphate solution? So when you come to Roman 1, this is what you have been given. So we have the volume we want to make. So the volume we want to make is 2.5 liters. What we have is molarity, which is 1.06 molarity. We also have the molar mass. We can get the molar mass of lithium phosphate, so which is going to be 6.94 times 3 plus 30.97 plus 16 times 4, which gives us 115.79. So the question is mass. So we know that moles is equals to mass over molecular mass. So if you multiply by molecular mass both sides, you get that mass is equals to moles times molecular mass. This tells us that we need moles, and we can be able to get moles from the molarity that we've been given. So we have been told 1.06 moles from the molarity are in 1000 centimeters cubed. That is what 1.06 molar means. So what about in 2.5 liters, which is the same as 2500? So when you cross multiply, you're going to get 1.06 times 2500 divided by 1000, which will give us the moles as 2.65 moles. So if you look at mass from the formula we just discussed, it's going to be moles, which is 2.65, times molecular mass, which is 115.79, which will give us the final answer as 306.84 grams. So you notice how in our calculation, we take what we have first of all, like where are we starting from, what have we been asked, and how can we be able to use what we have to get what we have been asked. So that's the basis of getting good grades in moles. Let's look at the second part of the question, what mass of lithium? So yet again, we are still looking for mass. We said the formula is moles times molecular mass. So we need to get the moles, but we have been given now 250 centimeters cubed. So we have been given the volume, which is 250 centimeters cubed. And we have been given molarity as well, which is 2 molar. So 2 molar means it's 2 moles in 1000 centimeters cubed. So if we use 250 centimeters cubed of the water, how much moles are we going to have? So it is 2 times 250 divided by 1000, which gives us 0.5 moles. So going back to our formula of mass is equals to moles times molecular mass. So the mass is equals to moles, which is 0.5 times molecular mass, which is 115.79. So which will give us a mass of 57.895 grams. So that's how you calculate those two questions. Let's do a few more practice. A chemist has 4.0 grams, so we have the mass of silver nitrate. So just indicate what you have. So 4.0 grams. Silver nitrate is AgNO3. So we can get the molar mass, which is 107.87 plus nitrogen is 14 plus 16 times 3, which will give us 169.87. And then a chemist has 4.0 grams of silver nitrate and needs to prepare 2 liters. So she needs 2 liters, that is the volume, of 0.010 molar. So we have also molarity, which is equals 0.010 m. So those are what we have like in our question. So let's look at what we have been asked to get. Will there be enough silver nitrate? If so, how much silver nitrate will be left over? So basically we have been told to calculate the mass. So let's calculate the mass of this reaction. So if you look at what we have been given, we have the molar mass, we have the volume, and we have molarity. So mass is usually given as mass is equals to moles times molar mass. So we need moles since we have molar mass. So moles, we can get it from the molarity. We said molarity is equals to moles over volume per liter, but not necessarily you use the formula, you can use the first principle. So we have been given molarity, which is 0.010. So 0.010 moles are in 1000 centimeters cubed. What about 2 liters, which is the same as 2000 centimeters cubed? How many moles will be there? So you cross multiply, which will give you 0.010 times 2000 divide by 1000, which will be 0.02 moles. So now that we have moles, let's look at the mass. So the mass is equals to, we said mass is equals to moles, now 0.02 times molecular mass, which is 169.87 that we had initially calculated. This gives us 3.3974 grams. But we have been told not all of it was used. We had 4.0 grams, but we only used 3.3974. So what was left over is you subtract 3.3974, which will give us 0.6026 grams. Roman 2, what would be the concentration? So we are being asked concentration if it dissolved only, so the mass is 2.0 grams and then the volume is 500 centimeters cubed. So concentration, the good thing with concentration, you can calculate it in moles per liter or in grams per liter. In this case, we can use grams per liter because of being given the mass. So if 2.0 grams are dissolved in 500 centimeters cubed, what about in 1 liter? It is 1000 centimeters cubed. So it's going to be 2.0 times 1000 divided by 500, which will give us 4. This is grams per liter. So if you want to calculate it in moles per liter, it still can work. So you calculate the moles is equals to mass over molecular mass. So you can decide to uh, the mass is 2.0 divided molecular mass is 169.87, which will give you moles of 0.01177. So 0.01177 moles are dissolved in 500 centimeters cubed. What about in 1000? So it's 0.01177 times 1000 centimeters cubed divided by 500, which gives you 0.02354 m. If you round off to two decimal places, which is going to be 0.02 m. So I hope you have been able to see how we prepare solution, especially this calculation. You notice we are using so many methods, but the key thing is to identify what you have in the question and what you are asked. If you're able to do that, then you can use the previous knowledge to calculate what you need. You notice mostly like in our questions, you were asked for mass. The first thing that we did was to get the formula of getting mass, and then we asked ourselves further, like in this case, mass is equals to moles times molecular mass, but we have the molecular mass, but we don't have the moles. So how can we get the moles using the information we have? So that's how you are able to calculate these questions. They are not that complicated. So see you in the next lesson as we continue with this topic.